Okay, students, after playing the games and watching the videos of the Pythagoras theorem, I hope you have the general idea of this Pythagoras theorem. Okay, now we go to the detail of the Pythagoras theorem. So as you can see at the left hand side, the diagrams, from the video, we know that area A plus area B equal to area 3, right? So although the video is talking about the volume of water, but actually it is a very good idea for us, okay, to visualize the Pythagoras theorem, right, by watching this video. Okay, so now we have the area A actually is the square box. So actually it's equal to A square, okay? And for area 2, actually it's also a square, so it's a B square. So when A square plus B square, it will equal to C square, okay? C square. So area 3 also is a square and the length is also C. So after we know this relationship, now we focus on the middle part, that is the yellow triangle, okay? We focus on the yellow triangle right now. So in this yellow triangle, there are 3 sides. So one is A, one is B, and one is C, right? And A and B we call the other 2 sides of the right angle triangle, okay? Or some of the book call the legs of the right angle triangles. These 2 sides actually they will connect it to the right angle. So A side connected to the right angle and B side also connected to the right angle, okay? This is a right angle. It represents 90 degrees, right? And C, we call hypotenuse, okay, which is the side opposite the side opposite the right angle, okay? So right angle is 90 degrees. And also C is the longest side of the right angle triangle, okay? So from the above relation, we can see the C square equal to A square plus B square. So actually this relationship is referred to the Pythagoras theorem. Okay, the detail of this Pythagoras theorem, it mentioned like this. In a right angle triangle, the square of a hypotenuse is equal to the sum of square of the other 2 sides. Okay, square of hypotenuse actually is C square in this case, is equal to the sum of the squares of the other 2 sides. We have A and B, right? The other 2 sides, the square of A and the square of B, okay? So this is a relationship you have to understand again for a right angle triangle, okay? Okay, I hope you understand the idea of the Pythagoras theorem. Now we do some warm up for exercise 1. Okay, as you can see, there is a right angle triangle. So first of all, you need to recognize where is the right angle, and the side opposite the right angle we call hypotenuse. So that P is a hypotenuse, and then the relationship according to the Pythagoras theorem actually is the square of the hypotenuse equal to the sum, okay, of the 2 other sides. So what are the 2 other sides? One is Q, that is connected to the right angle. Another side is R, that is also connected to the right angle. So Q square plus R square, right? So this relation actually is talking about the Pythagoras theorem. Okay, let's go to question 2. First of all, focus on this as a right angle triangle. So right angles here. And then we know that the side of the hypotenuse is A, okay, because it is the side opposite to the right angle. And then relation, we know that it is square of a hypotenuse, so actually it's A square equal to other 2 sides. The square are up to 2 sides, right? Sum of them. So C square plus B square, okay? So you can write B square plus C square, it's also okay, doesn't matter. Okay, so now we go to number 3. So it's I think it's similar. So length of hypotenuse, so the side opposite the right angle, so the hypotenuse is B. So that the relation between the sides, so it's B squared, sum of hypotenuse equal to other sides, it's the square of other 2 sides, right? So A square plus 2 square, right? And then number 4, focus on the right angle here, and then the side opposite the right angle is a hypotenuse, so it's 2. Okay, so the relation is 2 square equal to h square plus k square. Okay, so let's see the following exercise. Okay, so find the unknown of each of the following triangles. So then give the answers correct to 3 significant figures. Okay, 3 significant figures we have learned in the previous chapter, right? And then for part A, so let's see, it is a right angle triangle. And then first of all, we need to figure out the right angle. So here, and then the side opposite the right angle is the hypotenuse. So hypotenuse here is AC, right? And then the length of the AC actually is x. By using the Pythagoras theorem, so AC is equal to the other two sides, the square of the two sides, the sum. So AB square plus BC square, right? So AC is the hypotenuse here, and then the other side, sum of the other square of two sides is AB connected to the right angle, and also BC, the side connected to the right angle as well. Okay, so this theory is we call Pythagoras theorem, right? Okay, and then we just substitute the length of the side into this relation. So AC square actually is x squared. So A equal to 5 square, 5 referred to AB, plus 12 refer to BC, the length, right? So BC 12 square. So x square equal to 169 by using calculator. And then you want to solve x, so you need to take square root for both sides. Okay, so after that, x equal to square root 169, and then press the exe from the calculator, and then you got 13. Okay. For part B, the method is very similar, okay, to part A. So first of all, we need to recognize the right angle. So right angle here, and then second step, figure out the hypotenuse. So hypotenuse here is PR, okay, and the length is 7. So by using the Pythagoras theorem, we have the square of a hypotenuse. So actually, it's PR square will be equal to the sum of the square of the other two sides. So other two sides should be PQ connected to the right angle, and then QR, right? So equal to PQ square plus QR square. Okay, so this relation we call Pythagoras theorem, right? Okay, you need to write down the theorem at the right hand side of the equation, and then after that we just plug in the length of the side in it. So PR we know that is equal to 7, so 7 square will be equal to PQ square, so Y square is unknown, plus QR is 4 square, and then solve this equation. 49 equal to Y square plus 16. Okay, so you can simply 49 minus 16 equal to Y square, and then you solve 33 equal to Y square. Okay, so take square root for both sides, so Y will be equal to square root 33, so equal to 5.74456. There's so many decimal. Okay, but in this question, the question asks you to correct the answer to 3 significant figures if necessary, right? So now we need to, actually this concept you have learned in the previous chapter. So because 3 significant figures, so we have the first significant figure, and the second significant figure, and then third significant figure, right? And we also need to look at the fourth, because this is a fourth significant is 4, which is less than 5, so we don't need to add 1 for the first significant digit, okay, figures. So this part you can write on the draw paper, okay, and then so Y, the final answer is equal to square root 33, actually is equal to 5.74, okay. So this is the final answer, 3 significant figures. So, and after that, you can eliminate the draft, okay? So actually this part you can do it on the draft paper. Okay, student, after these two examples, what can you conclude? Okay, so these two examples, we still use Pythagoras theorem to solve the problem, right? But one is solve the hypotenuse, another one is solve one of the other two sides, right? That is connected to the right angle, right? So in these two different situations, but we still can apply the Pythagoras theorem, because you know, for a right angle triangle, if there are two sides given, any two sides given, by using the Pythagoras theorem, you can find out the third side. Okay, like the part A. Okay, so given 5 cm, this is the legs, and 12 cm, given two legs and ask you to find the hypotenuse. So given two sides, then you can find the third side. For part B, okay, still the question asks you to find out the legs, one of the legs, and then but given two different sides, one is a hypotenuse, another one is another leg, so that you also can find out the y. Okay, for a more capable student, actually you can try this following examples. Okay, here I can introduce quickly for this answer. So ABC is straight line, and then find value a, x, and y. So give the answer to three significant figures. So first of all, if we focus on the large triangle, so DAC, very large triangle DAC, there are two unknown, okay, throughout this right angle triangle, because this is hypotenuse, and DA actually is the one of the other two sides, okay, one of the legs. So there are two unknowns, so that we can't use the Pythagoras theorem to solve the problem. Okay, so we should focus on the small triangle first. Okay, this small triangle, because you guys can see that the small triangle DAB, right? DAB, you will find that there are three sides, but there are two known sides. Okay, two sides are known, only one unknown. Okay, so that if two sides are given, that means that we can find the first side by using the Pythagoras theorem, right? So that the answer is given to you here. So DB actually is a hypotenuse equal to DA squared plus AB squared, the other two sides, the legs, right? And then by using the Pythagoras theorem, and so that the hypotenuse 3 squared equal to the legs, one of the legs, x squared plus 1 squared. So you solve x squared equal to x, so x equal to 2.83. Okay, correct to three significant figure. Okay, and then now we have solved x, so x already done. Okay, so now we can go back to the large right angle triangle. Okay, because there are two known sides have got it. So phi is got it, x is got it, so only y is unknown, so that we can apply the Pythagoras theorem. Okay, so here, so we look at the large right angle triangle. So this is a hypotenuse, so DC actually square equal to DA squared plus A squared by using the Pythagoras theorem. And then y squared, okay, is the length equal to x squared plus 1 plus 5 whole bracket square. Okay, so y plus 5, because AC actually is equal to AB plus BC. Okay, so 1 plus 5 actually is the length of AC. So that you know now 1 plus 5 here. So y squared equal to 44, and then eventually you solve what is y. Actually, it's correct to three significant figures, 6.63. Okay, this actually is so. Okay, let's look at the last example. So this is a bit harder. So in this figure, the triangle PQR at the right hand side, okay, is an isosceles triangle. We have learned the concept of isosceles triangle in the previous chapter. So where PQ equal to PR equal to 5 cm, so PQ equal to PR, and then the baseline is QR, which is 6 cm. that question asks you to find the area of the triangle PQR. Okay, so originally, if you want to find the area of triangle, we just use the formula, right? So actually, it's base times height divided by 2, right? Or times half. Okay, but in this case, there is a base provided, QR, but we don't have the height of this triangle, so that we need to find out the height first. Okay, so how do we do? Because we have learned the properties of isosceles triangle, so you just follow the procedure like the diagram below here. So first of all, you need to choose a point on baseline QR such that QM equal to MR. So that means that M is a midpoint, so that QM equal to MR. And then you can draw a line pass through P and M, okay? And then this PM will be perpendicular to QR, okay? So this is the properties of the isosceles triangle. So if PM is perpendicular to QR, that means that PM here is the height of this triangle, okay, because it is perpendicular. That means that this PMQ, this triangle actually is right angle triangle, okay? So let's see the right angle triangle to see any sides are given. So this hypotenuse is given, okay, and the height is unknown. And one of the legs is known, okay, which is 3, because M is the midpoint of QR. So QM actually is equal to 3, right? So now with two given sides, we can find out the first side, okay? So by using the Pythagoras theorem, okay? Okay, let's focus on the right angle triangle, PMQ. So just by using the Pythagoras theorem, okay, with two known sides, we can find the first side. So PQ square actually is a hypotenuse, okay, equal to PM square plus QM square, right? Can you see that? So PQ square here, okay, equal to PM square plus QM square, right? So and then phi square equal to PM square plus 3 square. Just substitute the number inside, and then finally you find out PM square equal to 16, and take square root for both sides. So PM equal to 4 cm. Okay, so this is actually 4 cm is height in this triangle, right? Okay. So finally, the area of the PQR we can solve right now, okay, by using the equation of area of triangle. So actually is half times base times height. So half times base, which is 6, and height is 4. We just find it. So that the area of this triangle is 12 cm square. Okay, so how we understand this? Okay, to conclude this lesson, I hope you understand what is Pythagoras theorem, okay, which is the square of hypotenuse. So in this case, c square equal to the sum of the square of the other two sides, so which is a square plus b square. Okay, so there are many other proofs for the Pythagoras theorem. So the games, the video, only the example of the proofs. So you also can try to figure out other proofs of the Pythagoras theorem. So it is very interesting. Okay.